Original, actually.
Yeah,
Nope,
we are
but
live.
there we are. We're live now. Greetings, fellow nerds. Welcome to another episode of Between Two Nerds, where we talk with prominent industry guests about all aspects of the networking industry, from protocols old and new to industry trends and drivers to up and coming technologies. And as always, things you need to know to further your career. Good morning, Jeff.
Good morning, Jeff. Actually, good afternoon by now.
Oh, that's right. I being in even here in Denver, it's afternoon now. So you were we did a show without you last week. You were off in Prague at IETF.
Yep.
How'd that go?
It was very exciting. Also, short idea for me, just 3 days. I had to be someplace else. Be in morning in Prague, afternoon in London, and then in Paris. But, you know,
Nice.
that's the way we do it.
Yeah.
So we did the AIDC meeting, which is not kind of topic of this discussion, but very successful. We've published the uh, video recording, so please do watch it. It's very informative and would benefit your understanding of why AI needs what it needs in terms of bandwidth, utilization, all the semantics of it, how you distribute models that's larger than one GPU across tens of thousands of GPUs, kind of stuff. So it's all recorded.
Cool. Yeah, I'm going to look for it, and hopefully everybody that's on with us will look for it also. So our guest today is Lenny Guiliano. I'm sure I just butchered your last name because I'm old and my tongue doesn't work all that well. But thank you for joining us today. And maybe the place to start of all things is explain your T-shirt.
Um, well, I've watched an earlier episode, and Jeff T had a great Notorious BGP shirt, so I figured I had to keep up. And
Oh, it's in the wash right now.
yeah, uh, yeah. So the technology,
Your T-shirt is relevant to our topic today, though, right?
it is. It is. It's relevant, and the technology is an architecture called TreeDN. It is a tree-based CDN architecture, and it's optimized for live streaming to mass audiences. So, a key component of it is automatic multicast tunneling (AMT).
Cool. Yeah. So, we had Dino Farinacci from Cisco on a few weeks ago, and well, maybe more than a few weeks ago, that did a really good overview of the history of multicast and sort of a little bit about where multicast is going. And this is a great follow up to that show. And we were talking about it before we went live. I'm pretty sure your name came up in that show. And
Lenny is part of multicast history. I still remember 50 or so years ago, Tony Lee pointing at him.
Yeah.
Saying, this is the guy who really knows multicast. So.
Appreciate it.
So maybe a good place to start is and I should mention, for anybody that is watching, if you want to follow along on this, it's a fairly short internet draft, but if you just go to the IETF site and search for TreeDN, you'll find the internet draft that Lenny is a co-author on, and it's pretty much where our discussion today is centered. But maybe you start there, and I've got the internet draft up here on another screen, and I'm just looking at it right now. But the problem statement that you have, really three problems around the idea of multicast across the internet, meaning not just within a closed environment, and where there's a lot of control over the entire path, the entire domain, maybe is a better way to say it. But I think about things like sporting events. I'm a baseball fan and subscribe to MLB TV, and so my wife and I are watching baseball almost every night during baseball season. I'm an opera fan and subscribe to some opera channels, but those are the ideas that popped into my mind. It's things that I'm just in my house, obviously connecting to a service across an internet or across the internet, and trying to get content across the internet is sort of the major problem, but then there's sub problems to that, right?
Yeah, so it comes down to really scale. So what's really interesting is we're finally at a point in time, and I think this is very, very recent as I think a key moment was about a year ago when Amazon Prime had gained exclusive rights to Thursday Night Football for streaming, and that was really the first time. There was like one event before that. It was kind of a one-off the season before, but last year was the first time where NFL football, American football, was available exclusively through streaming. The only way you could watch it, at least out of market, was streaming. And last year was a lot of people were sitting back and very interested to see how this was going to work. And they had audience sizes of about 10 to 15 million live streams each Thursday night for 3 hours a night for 16 nights a year. This year, NFL Sunday Ticket exclusively being streamed, or the exclusive rights are over streaming with YouTube TV, and that's the average NFL football game has about I believe 10 to 15 million viewers. So these are and they have 7 to 10 games per every Sunday, and more recently the cricket. There's been some massive cricket events. In June, there was the IPL championship, and that I believe it's India Premier League had 32 million concurrent live streams, and just this morning I read the Cricket World Cup. They announced they had 53 million simultaneous live stream viewers. So audience sizes are exploding to tens of millions now, almost semi routinely. Combine that with bit rates from there's high def, and then there's 4K, 8K, and then thinking further, think augmented reality. The ability to do live stream on augmented reality. So it's really a demand issue. Up until now, I don't know that we've ever needed. In fact, we know this because multicast. What multicast has been around for a while, and I think the lesson that can be learned is we haven't needed multicast. CDNs and unicast and brute force unicast has been good enough. The question is, can it continue? And are we reaching an inflection point where brute force unicast is just really, really inefficient and can't get you to the next point? It is just about good enough for delivering content that is pretty much what television has been doing for 70 years. And the internet is supposed to be about something better, not just, we aspire to be almost as good as what television has given us, for 70 years. No, it should be much better. It should be more immersive. It should be a much better experience. And, right now, a perfect example is with Thursday Night Football. Amazon Prime is not showing those games in 4K. And, with essentially all the resources Amazon has, they have spared no expense to deliver this, and you only have to go to a recent Nanog. It's clear they are really focused on delivering an exceptional experience for Prime viewers. But with all their resources, and I've read they're dumping traffic on 5 different CDNs, and they are going brute force unicast. They still can't deliver it in 4K. So that's an indicator of something, right? And that indicator are the bit rates so high and the audience is so big that you just can't do it. So TreeDN is a new approach. It's an approach that's way more efficient for delivering this kind of content, this kind of live stream content, live stream video content. Really, it could be any kind of multi-destination traffic, but the sexy, interesting traffic that people would really care about is live streaming video. And TreeDN is essentially an architecture that it's nothing new. But what it does is what's new and unique and novel is it's the synthesis of a bunch of things that have been around for a while and kind of putting them together into an architecture that really solves a problem. I would argue it was a problem we thought we would need 25 years ago when Multicast came out, and we really haven't. But I think we're finally hitting that point where we need to do something a little bit better than what we're doing right now, because it's really expensive and it's really difficult. And we can't go much further if you want to do things like 4K and 8K and more interestingly, something like augmented reality.
Yeah, I remember. In addition to all of that, I remember you saying in another presentation. I think you gave the example of differences in latency or delta in latency between different receivers, which actually becomes significant. And if I remember, if I'm not making it up, you were talking about sitting in maybe your apartment watching a game, and something exciting is about to happen, and you hear your neighbors all cheering over something, and then it the touchdown or whatever happens on your TV. So obviously a difference in latency between what your neighbor is getting and what you're getting.
That's on life, right?
Yeah.
We've been using Multicast for a long time to pre-distribute content across edges of CDNs. So all those networks are Multicast enabled. It just when it comes to the live distribution, suddenly none of this works again. And there's millions of unicast flows, obviously killing any network. So you need to over-provision your network for the 16 days a year to be able to deliver this content. Yeah. And kind of coming back to what you're describing, it's not something new that we need to build. Again, all these networks are already Multicast enabled for a variety of different reasons. So it's a very pragmatical approach on top of it to reuse it.
Yeah, so there's kind of really two things there. So first, live is different. I've heard people say, "What's the difference? Live streaming, on demand. What does it matter if somebody's watching a game versus they're watching a Netflix movie?" There is a huge difference. So with a Netflix movie, you can have a 1 to 2 minute playout buffer to smooth out any packet loss or drops or latency issues, because it's a movie, right? You can wait a minute to watch the movie. It was made, a year ago or many years ago. When it comes to live sports specifically, you can't have a 1 to 2 minute playout buffer, because you're going to get a text message from your friend about the game winning score, or you'll hear people cheering, at the bar across the street for a minute before you. So, there's a latency budget of about, let's say 10 seconds to match what broadcast television has. And you really want to kind of match that. The other thing is, and if you want to go even tighter, there's a world of opportunity in the world of micro betting, right? So micro betting is where you can bet on little things like this next pitch, is it going to be a strike or a ball? This next football play, is it going to be a pass or a run? Are they going to score on this series? Something like that. With that, your latency requirements are like less than a second. It actually begins to look like financial transactions. And if you think about, financial networks, how do they handle this? They use Multicast extensively. So, Jeff, Jeff T, you mentioned Multicast has been around, hasn't it? And the answer is yes. And I think I watched the episode with Dino, recently. It was fantastic how he talked about the history of Multicast. I think TreeDN kind of is a great epilogue to that, because it builds upon what we learned in the last 25, 30 years, what worked well, what hasn't worked well, and how we can apply those lessons to deliver a service that is useful. Specifically, is it Multicast in use? Yes, but so Multicast, and Dino and I have had this conversation. Is Multicast a success or a failure? Right? I think I've asked this question, and I think it's true, but I have no data to support me. I'd be willing to bet there are more routers on the planet today running PIM than there are running MPLS. I have no data to support me, but I've said it before, and I've never had anybody disagree with me, and I think it's true. Everybody thinks MPLS is a stunning success, but the truth is the bar is really low, because MPLS is kind of a single domain solution for the most part. You could have interdomain stuff, of course, but what MPLS is really useful for is and kind of designed for was just within a network. Multicast, on the other hand, has a super high bar. So Multicast has been incredibly successful in some places. Financial networks, I mentioned, it is critical. Video distribution networks, Jeff, what you mentioned. Just about anybody doing video distribution is distributing the content from a cable or from a satellite downlink to the head ends, and that's how they push stuff out, right? Mm-hmm. It's multicast VPNs. Any VPN service, multicast is kind of a checkbox. You kind of have to have it, and a lot of enterprises have used multicast extensively. But each of these examples are really walled garden networks, right? And multicast, I would say, has been pretty successful in walled garden networks. But internet multicast, over-the-top multicast, getting it to the house, to the phone, to your TV, that has not been a success. That's been I would say, an abysmal failure. There is very little to no parts of the internet are multicast enabled. And that's what TreeDN is trying to solve. It's trying to understand, all right, what went wrong, and how can we overcome these barriers, and that's and deliver a service that is useful and solves real business problems. And I think we're at that point where it does.
I know that in the talking about the reason it maybe multicast is not, I don't want to say not a workable solution, but as you said, not a successful solution over the internet. And you lay out 3 problems around that. And I'm just reading right off your internet draft. The all or nothing problem, the it's too complex problem, which I think is the one that anybody that's dealt with multicast immediately thinks, and the chicken and egg problem, which is interesting in itself. Can you talk about those?
Yeah, so the all or nothing problem is basically, for multicast to work, you need every single layer 3 hop between source and destination to support multicast, right? And what that practically means for internet multicast, every single interface on every single router and firewall on the internet needs to support a multicast routing protocol like PIM. And that is just an incredibly high bar. And it's not unique to multicast, because the V6 people have been dealing with the same problem. Yeah. Slightly better. They're doing a little bit better, but not much. After 30 years, they're still struggling. And I would say both multicast, I say multicast and V6 are kind of like technological cousins. They're related, and both of them, were born in the 90s, and there was great high hopes for them in the 90s, and here they are. They've been around a while. I'd say multicast is more success. V6 is probably the slightly more successful cousin. But both of them, I would say, are living at home in their parents' couch with, their parents are still a little nervous about whether they're ever going to leave the couch and make it out, out in the real world.
I think Lenny just froze.
Layer 3 hop to support it.
There we go. You froze up for a second. Can you repeat your last sentence?
So V6 and multicast have that same problem, where you need every single layer 3 hop to support it. So that's the all or nothing problem, and that's just a fundamental availability problem.
I should mention on V6, because I've been involved in that world since the 90s. The only reason it might be slightly more successful now, as you mentioned, is just because there's no choice anymore. We've pretty much gotten to where all the addressing authorities are saying, sorry, no more IPv4 addresses, so there's no more alternative there. So that tends to be.
There's certainly pockets of V6, right? There's certainly pockets of V6 where it's been successful. Yeah. But there are extensive parts of the network that are aren't going to be anytime soon, right?
Yep, Absolutely.
So that's the first problem, the all or nothing problem. The second problem is the complexity problem, and you nailed it. There is if you went to a nanog, you would have a large support group of people who will tell you they hate multicast because it's way too complex. Because in 2007 I hit this horrible PIM assert bug or some MSDP SA storm, and I hate multicast. And it's I like to tell them, look, guys, things have changed. Give it a shot. Believe it or not, things are a little different in the last 15 years. We did learn our lessons. We agree MSDP is terrible and PIM has all these weird corner cases. So basically, where the perceived benefit does not exceed the perceived cost, it's not deployed.
Mm-hmm.
And the converse is also true. So on places like financial networks, they absolutely need it. They deploy it. On video distribution networks. Again, they feel like it's a really useful and powerful tool. And both of those again are walled garden networks where you can reduce a lot of the complexity because they're single domain for the most part, and you don't have to deal with the issues of interdomain. But on the internet, it's perceived. Operators just perceive it to be, this is too much of a headache. I don't want to do it. And again, TreeDN addresses
the reality. Sorry, go ahead, Jeff.
Indirect hint to that is really beer development, right? So beer on itself requires very different forwarding architecture. It took some time, but you see across all of industry, we changed our forwarding engines to support beer. And believe it or not, it took millions of dollars to develop it. So there's significant investment into replication technologies such as multicast. And again, no vendor will do something unless there's a customer paying for it, right? So even if you don't see it, you should realize that there's a lot of demand for these technologies and it's actually happening.
Yeah. And you mentioned, you made a parallel with MPLS earlier, and like MPLS, what a lot of people will recognize, it's a very broad statement for people to just say, multicast is too complex, because there are layers of complexity. MPLS in itself is not all that big of a deal unless you start implementing traffic engineering and RSVP and all these kind of things, fast reroute. And, so, you can make it as complex as you need to be, but it doesn't necessarily have to be all that complex, which probably leads a little bit into TreeDN.
I would say this complexity is a funny thing. It's one of those things that people like to use as a conversation ender to do something they don't want to do.
It's skill.
Good point.
Yeah, and scale. Yeah. So I remember meeting with a customer once, and this was a long time ago, 20 years ago, and they were like they were doing RSVP over LDP, IPsec over RSVP over LDP, with traffic engineering. And it was like a mind-blowingly complex thing. And I'm like, well, you ever think about running multicast? You're like, oh, it's too complex. And whenever I look at like EVPN, and I mean, they don't even try to make EVPN like there's route numbers and no names of things, and it's like it's as if robots invented the thing, and you look and you EVPN I think is mind-numbingly complex, and yet everybody loves it because it solves a problem, and people are willing to tolerate complexity if the benefit is greater than the complexity they're willing to deal with it. And it's also about familiarity, right? If MPLS, for me, I've been working with multicast for a long time. I think it's the easiest thing there is. And I could, give me a whiteboard and, a half an hour, and I feel like I could teach anybody, and at the end of it, people are like, yeah, I get it. That makes sense. It's not too bad. This isn't horrible. The problem is if you don't work on it every day, and this was the typical problem. People would get it up and running. They would know how multicast works, and then they would leave it up, and then it would break 4 months later, and they forgot how it all worked. And then, for a week, they would relearn how it all worked, and it would work again for 6 months, and then it would break again, and nobody was around to fix it. So So yeah, complexity, I think, is, again, it's in the eye of the beholder. It's no more complex than anything else. I mean, ISIS has these really weird addresses, and nobody really knows how ISIS works. They just turn it on and leave it alone, and it's like a chainsaw that just stares at you, and you look at it and like, that's really powerful, but man, it looks at you like, I want to chop your arm off. I will happily do that. And that's kind of to me how ISIS works, and that's why people like don't configure any knobs on ISIs. You turn it on, set the costs, and leave it alone, and just hope it's doing what it's supposed to be doing, and pray you never see a bug or an issue with ISIs. But I think multicast is no more complex than anything else we do. Look, we wouldn't be you wouldn't be nerds if this stuff were easy, right? Then anybody could be doing this. It wouldn't.
Yeah, you know what Tony P said about BGP is Swiss Army knife without handle.
Yeah. So, Jeff, you mentioned beer. So one of the nice things about TreeDN is it's agnostic to technology, to whatever technology you want. So it has these two components, a native component and a tunneled component, or an overlay component. And the native part can be any technology. It can be running PIM, MLDP, it can be running beer, whatever you want to run in the native part that you like. That's fine. It doesn't pick and choose,
which is fundamental to TreeDN kind of deployment strategy, right? We are not really looking for revolution networking. If anything, we are looking for evolution. We want to reuse existing assets, investments. So ability to reuse any existing technology that can be used for replication with TreeDN, I think, is one of the major potential drivers to success.
Yeah, and it's also, it cares about delivering the service, and it's not dogmatic about how, right? I would say, one of the early mistakes that we all made, in the late 90s, early 2000s, was really focusing on trying to get people to deploy natively. And, there was this push to go native. And again, with that all or nothing problem, it's just such a high bar to get everybody in the world that run, any routing protocol on every router, right? So consequently, there was no incremental deployment. There was no, it was such a huge lift, and there was no easy transition way to get there. What TreeDN does is it says, look, we want to deliver a service. We want to get a packet from one place to a bunch of other places really efficiently. And we don't really care how it got there. If it took an overlay or it took native path, either way, as long as the packets get there, we care about the service, so that a content provider can know they send packets out, and the interested receivers and the audience gets those packets.
Lenny, so traditionally, multicast has been criticized for lack of reliability. And I mean, it's stateless for a reason, right? That's how you scale. But so how do we address this kind of concerns with TreeDN?
So there's two ways to look at that from a reliability. Are you talking about from a transport perspective? These are, unreliable packets as opposed to, UDP versus TCP, or is it unreliable as in, the routers break when I turn it on? I'll kind of address both. So the unreliable part is, from a transport perspective, unreliable transport. Guilty as charged. Multicast cannot rely upon TCP to deliver and guarantee packets will make it to their destination. So and that's not a multicast problem or a unicast. It's a UDP versus a TCP thing. So multicast kind of inherits all of the issues as well as the benefits of UDP. Right? There are some benefits, and TCP is great from a reliability standpoint, but not so great from a say throughput standpoint. And there are issues with TCP. One of the nice and exciting advancements is QUIC, right? So QUIC is like, and I'm forgive me, I'm a layer 3 guy. I don't really understand layer 4 transport too well, but my primitive understanding of QUIC is it kind of gives you TCP like setup with UDP like delivery of the actual data. But it is UDP, or it is UDP-like. It is not TCP. So there's actually a draft out Jake Holland, I mentioned him from Akamai. He's really done brilliant work over the years, and he's been working with Max Frank, a professor in Europe at a German university, as well as Lucas Pardue, who and they have a draft out that is multicast extensions to Quick, and I think there's a lot of that solves a lot of the fundamental layer 4 issues that have been a concern with multicast. So I would say multicast extensions to Quick are one solution. But that said, people are doing live streaming with UDP, and they have been, and it not necessarily Quick. So, for example, those who pay attention to this kind of thing may have noticed a couple of years ago, Amazon purchased a company called Psy, and they do live streaming with UDP, which is an inherently unicast-friendly transport. And it's hard not to notice, the order of things, but that happened before they got, before they went out and purchased the rights to Thursday Night Football. So there's a lot of speculation that that Psy technology, which is UDP based, was one of the key foundation technologies that Amazon Prime was going to use. I don't know under the covers what's really happening, but I can tell you there are those who do use UDP to deliver live streaming content even for unicast. So that's kind of the unreliable transport part of your question. And then there's the, unreliable, will it break my network and melt my network down? And that's really where that's kind of one of the key components of TreeDN. I should have probably mentioned, what is TreeDN? It's essentially SSM plus AMT, and those are the kind of the short form versions of it. It's really native plus overlay, but the native part of multicast is native multicast forwarding, and the key scope sandboxing that we did is just do SSM. So people complain that multicast is complex. Well, it turns out multicast isn't complex. It's network-based source discovery is complex.
I was going to exactly this point with you.
Yeah. And we asked multicast to do something we would have never asked unicast to do. When you ask the network to essentially routing protocols to go find all the sources, of course it's going to be really complex. And it's because of a fundamental assumption that, was made kind of at the beginning, which is, the network, there could be many sources to a group and the network's going to find them all magically. That was the original vision for multicast. It was called Any Source Multicast, ASM. Well, it turns out, that sounds great for things like video, video conferencing and multiplayer stuff. But A, it's really complex, and B, it's actually a DOS attack waiting to happen. Because if you end up joining any source to a multicast, then anybody can just start blasting away garbage, and you're going to join that content, and you can get DOS. So what SSM does is instead of a receiver just telling the network, I want to join group G, go find all the sources for me. It said that end host says, I want to join group G from source S. You specify the source group pair, and the network doesn't have to find the source. The network knows who the source is and can join just on the source. And by doing that, we've eliminated 90+% of the complexity of multicast because we've got rid of rendezvous points. We've gotten rid of PIM register messages being encapsulated and decapsulated. We've gotten rid of shared trees. We've gotten rid of tree switchover from shared tree to SBT. We've gotten rid of data-driven state creation. All these things that have plagued, all these things that when people complain about the complexity of multicast, that's what they're complaining about. And we've made multicast super simple. It's just PIM joins and prunes going back and forth between the source and the receiver on a straight line on a shortest path tree, and life becomes much simpler.
So SSM is the best thing that could have ever happened to multicast, right?
Yeah.
And you would be surprised how much SM is still deployed, especially in data centers.
It is, and a lot of it is, there was an effort, We wrote a draft that's now in RFC to essentially deprecate ASM for interdomain purposes. And this is kind of like, it was a poorly kept secret in the, and it was a well too kept secret because it wasn't a secret. These are things that all the multicast people knew. It's like, don't use ASM, just use SSM. But we had never given clear direction to the rest of the world. And so app developers, set-top box developers, they just kept doing what was going on in the 90s because it was a little easier. But it's not that much harder to build source discovery. In fact, it's way more flexible to have source discovery in the application layer. And if the application was discovering the group address, it should be able to discover the source address roughly just as similarly.
Let's describe the problem statement for SSM, right? There's no free lunch. So in SM, we just use rendezvous point where senders and receivers would meet and establish S-comma-gist or qualified path, right? In SSM, someone needs to distribute this information to the senders. And you remember SDP, it wasn't a good thing to do. Practically, the distribution of this information belongs where it should be in management plane, but there's no clean solution in single domain, in multi-domain, doing it in secure way, in a way that multi-domain players or consumers of this information would actually agree on it. Key distribution on top seems to be the problem. What's your view on this?
Yeah, I mean, it's just imagine, would we ever ask OSPF to keep track of every web page on the internet?
We could.
I mean, that would be insane. Or BGP, just, keep track of every single web page on the internet. Like, that would be insane. But we did that with Multicast. And so we can talk about MSDP, a horrible protocol, everybody hates it. But, to me, MSDP is not, is a symptom. It's not the root cause. It's like MSDP is not the problem. It's not the criminal. MSDP is really just driving the getaway vehicle. The real criminal here was source discovery, network-based source discovery. So anyway, it's a long-winded digression. TreeDN, the native component is SSM, and so SSM solves the fundamental complexity problem. We talked about the three problems. I think I only made it to two, but the number two of it's too complex. We solved that with SSM, and then the next part is the overlay, which solves the other two problems. So the third problem for those viewers who are wondering, gee, what happened to number three? That's the all or nothing. I'm sorry, that's the chicken and egg problem. There's no multicast content because there's no multicast audience. There's no multicast audience because there's no multicast content.
Yeah.
I'm sorry, kind of to come back to my question. How do you see the distribution of, S-comma-gist for lack of better terminology? Because you need to do this in management plane, right? When sender sends it, it has S-comma-G to send to, right? So you need to distribute this information, and in multi-domain scenario, it seems like there's security, those are different entities administratively. How would you do this?
So there's a couple ways. The short answer is PIM SSM, which is really just a subset of PIM sparse mode. It's just the S-G parts, no rendezvous points, none of the shared tree behavior. So again, going back to when people complain about PIM, they're not complaining about the shortest path tree part. That's the easy part. It's all the other stuff that they hated about PIM. Now, that said, you don't need PIM. PIM SSM is the most commonly deployed multicast routing protocol. There's also MLDP. There is also GTM, Global Table Multicast, which is essentially we stole the BGP MVPN control plane messaging, and we applied it to the master routing, the global routing instance. So you could use that. Beer is really a data plane, and it still kind of relies upon some type of control plane. So you could use offline controllers. You can, and there's also a draft in the best working group called BGP MCAST, which essentially, if you think about it, BGP MVPN kind of started on that pathway to having BGP kind of do the job of what PIM was doing. And then GTM kind of took it a step further and said, all right, we're going to do this beyond just VRFs, and we're going to do this in the global routing instance. And then there was also, using BGP as a CE to PE protocol for multicast. So like the next step is, well, gee, it feels like we've sort of kind of replaced PIM with BGP for just about everything. Let's finish the job here. And so that's what essentially BGP MCAST is, which is using BGP to fully and completely solve every use case and replace PIM. So, your question of how would you do it? You could do it today with SSM, with BGP, with PIM SSM or MLDP or anything else. But for those who are concerned about, the PIM is a soft state protocol, and soft state protocols only scale so far, right? And it certainly scales much better than ASM because you've eliminated the data-driven state creation events. So SSM is way more scalable, but can SSM scale to tens of millions of PIM routes? Or can PIM scale to tens of millions of S, Gs? Probably not. I don't know that it ever will. But I should say this: there are people who there's a thing called PORT, PIM over reliable transport, which is kind of making PIM a hard state protocol. There's that too, but really the answer is BGP. And I think BGP MCAST for a world where we do have, tens of millions of BGP routes. If we are to ever get there, you're probably going to need BGP to do it. And BGP has demonstrated the ability to carry tens of millions of stuff on routers.
Cool, thank you.
Is there anything for which BGP is not the answer for?
Yeah, I've heard, Shakespeare over BGP. There actually was a draft, and it kind of died and sort of got slightly resurrected. It was like almost like BGP tweets. It was it's about 15 years ago. You could send literally text messages via BGP, any unstructured text. So you could send, the idea was you could send a neighboring knock, hey, I'm going down for maintenance, or
we implemented all of this. The BGP-wide communities, hey Jacob, and there is notification message. So you initially do it today.
Yeah, or you could imagine, hey, here's my resume. Are you guys hiring? You could send those through BGP. It ended up being there's now an RFC. I forget which one it is, but it's where you just send an opcode for what you're about to bring a BGP session down for. But it was way more ambitious and interesting, to be able to send pure, text. And that was kind of neat. But yes, BGP can do anything. There are some people who find that hard. But by the way, that's an interesting point you make that. It kind of there are some people who are cringing and who will say, this is protocol overloading, and we shouldn't be overusing BGP. We're going to break BGP by doing it for all this stuff for which it was never meant when that napkin was made that Jeff likes to show, right? And Multicast has an interesting counterpoint to that BGP overloading question, right? And some of you may have remembered, there was a big this about maybe 12, 13 years ago, a big issue on protocol overloading, BGP overloading, putting too much stuff in it. In the late 90s, early 2000, 90s, there was a question of where do we put what protocol should we use to tell RPs about sources they know about? And there was a thought, let's do it in BGP, let's do it in MBGP, right? We'll create another NLRI. And there was like, no, we can't do that. We'll break BGP. Let's create a new protocol called MSDP.
Which looks and smells like BGP, but not.
Yes, it looks a lot like BGP. But that's a good counterpoint because you know what? Creating a new protocol didn't make it any better, right? Yeah. And that's kind of the point. It's not the protocol. It's not, it's the function of the protocol. So you can call it whatever you want. You can call it MSDP, you could call it BGP, and you could take MSDP functionality and put it in BGP. But and actually that's exactly what type 5 routes are in BGP and VPNs, right? So you can do that. But you can make it a little bit better and make it scale a little bit better. But ultimately, you're doing the same thing, which is having the network keep track of a globally synchronized database of every single multicast source on it. And that just, that's just the wrong way to approach this. Better to leave that out, put that in the application layer, and let the network just stay simple and forward packets.
But looking especially at last 7 years in retrospective networking industry, I would definitely prefer this in control plane rather than abusing some part of IP address and hard coding the stuff in ANA. The argument discussion, right? I think this is.
How many more fights do we want to start? Let me just say this: I certainly do have opinions on that as well. Would you rather embed semantics in a packet, or would you rather embed that state within the router? Far more eloquent people can talk about that. Here's what I'll say: I'll take the easy way out and say, you know what, TreeDN can support both. So we can do tree sit, we can do beer, which embed semantics in the actual packet if that's what you want, or we can do it with PIM or MLDP. We're not discriminating. We have a very open tent. All are welcome.
All inclusive.
Yes. Yeah. I mean, is it fair to say that the whole idea of TreeDN is a packet going from the source to some consumer somewhere out there is just using whatever resources it can get along the way to get there? So there's no point to it that it says, well, I can't go any further than this.
Right. So I've talked about the native part, and that again can be any multicast routing protocol that forwards packets natively, and any forwarding technology that does that. Then there's the overlay, right? So that only works for the native part of the network, but 99% of all users are on non-native parts, are on unicast only parts of the network. So how do they get the packets? And that's where the overlay comes in. So when I started in this business in the late 90s, tunneling was seen as a suboptimal hack to be avoided and eliminated. But if you call it overlay network, it turns out if you just rename it overlay network, all the cool kids are doing it. So we are jumping on that bandwagon of fashion, and it's very fashionable to do tunneling, and we just call it overlays. As long as you call it an overlay and not a tunnel, people will think it's cool.
You sound intelligent, yes.
Yeah, so overlay networking is what all the cool kids are doing, and that's what AMT is really all about. And
automatic multicast tunneling, I think, in case we haven't defined that acronym yet.
Yeah, so what automatic multicast tunneling does is it does just that. An end host, like a smartphone or a laptop or an Amazon Fire Stick, perhaps, or a smart TV, can dynamically build a tunnel, a UDP tunnel, to what's called an AMT relay. The relay is the tunnel server, and the gateway is the client. So it's kind of a client-server thing. And the client can build a tunnel dynamically to some router on the border of the multicast-enabled network, set up this dynamic UDP tunnel that it sets up. It sends an IGMP report through that tunnel. So that tunnel server, what's called an AMT relay, the AMT relay receives that UDP, it receives that IGMP report, turns it into a PIM join, and receives the content natively, and then sends it over the tunnel. So the end result is end hosts on unicast only networks are able to access multicast content, and they are not dependent upon their upstream service provider to support multicast. They just tunnel right over them. So what does that mean? What does that get you? First, it gets you a lot of benefits. First and foremost, the people who, or the networks that support multicast natively get the benefit. So the benefit extends to the extent that the native multicast network extends. So if you deploy multicast, you get the benefits of multicast. You get to enjoy it. Whereas previously, without tunneling, overlay networking in AMT, you built this multicast network and nobody could use it because none of the receivers, could actually, none of the interested receivers could get this content. But now with overlay networking, you build this network and people can actually get traffic. And so for those networks that haven't turned multicast on, we just tunnel over them. So they don't enjoy multicast. It's just unicast streams to them, and they're carrying a bunch of duplicate unicast streams. But those who, the multicast content providers and the multicast native providers, transit providers, get the benefit of multicast. And those who haven't turned it on haven't. So a few things you get there is, one, those unicast only networks suddenly now have perhaps an incentive. If they're carrying a ton of duplicated unicast traffic, UDP streams, they may say to themselves, gee, this is, finally hit a critical level where it actually makes sense for me to turn on multicast. So you could think of AMT as kind of like a transition. It's a critical transition mechanism, which gets it working, but gets it working kind of suboptimally to the part of the network that's being tunneled over. So it really incentivizes networks to turn on multicast natively. So that's it's a scalable technology because I only create this tunnel when I need it. If I want to join a multicast, a video stream, I create that tunnel, I join the tree, I join that, I receive it, and then when I tune out, that tunnel gets destroyed. So it can scale to just the number of actual interested viewers at that time. So that's the beauty of AMT is it's kind of a dynamic tunneling mechanism, and it delivers content to the end users. So that's how it solves the two problems, number 1 and 3, which is the all or nothing problem. We're tunneling over the parts of the network that aren't multicast enabled. So we can live with the network as it is. We don't have to transform the network and make everybody native. And the second thing is it solves the chicken and egg problem, because now the entire internet is a potential multicast-enabled audience.
Not to forget, while unicasting, you are benefiting from FRR or any resilience technologies that are in place, because it's just IP traffic from their perspective. You don't need all the state synchronization you would usually have in like complex multicast deployments. Like
and
we are to MLDP in a way.
Yeah, and you can get FRR with multicast. One of the other technologies that I didn't mention, point to multipoint RSVP. Point to multipoint RSVP, you can get fast reroute with that if that's what you want to do in the native part as well. So
yeah,
but yes, there are nice parts of overlay technologies, which is you are completely agnostic to what is going on. And I say AMT is a transition mechanism, but there are certain parts of the network that will never be multicast enabled. Say it has, there's legacy technologies, legacy access technologies. It's never going to support multicast. Well, that's fine. You can use this as kind of a bridge to get you across and get multicast content there. Also, multicast over Wi-Fi. Wi-Fi experts will tell you multicast is a big major headache. There's a really interesting draft on the problems of multicast over Wi-Fi. I don't think it's as applicable, to be honest, in the home, but it is applicable in places where you have lots and lots of a dense distribution of receivers on the same Wi-Fi wireless LAN. And so AMT can kind of solve that problem as well.
So there's a question on the chat. How is the nearest AMT gateway discovered? Is there any database or DNS entry for it? Anything? Yeah.
Wow. So Andy, you've kind of answered your own question. So the first answer is there's many different ways. Not to sound like ChatGPT, there are many different ways to discover and it's actually the AMT relay. So the gateway is the client, the relay is the server, and you want the client to discover the server because the tunnel is initiated by the client. So it's initiated by the gateway to the relay. Now the question is, how does the gateway find the relay? So there's different ways. Jake Holland wrote a draft called Dryad, and he describes a way to do this with MDNS. But the short answer, so I'll give you kind of a hand wavy answer. One, the relays can be one of the ways of doing this is have your relays be Anycast. So you can have just a set of Anycast relays and you just get routed to the nearest one. That's kind of the best solution. And in fact, the AMT spec even defines a block of addresses that are globally routable, that are Anycast. It's for, essentially if you wanted to do a single pool of global Anycast relays. That said, that's kind of a DOS attack waiting to happen, because if anybody in the world can claim I'm a relay, then anybody in the world can claim they're a relay. So you do want to have only really trusted relays. So I think interdomain Anycast probably doesn't make a whole lot of sense from a practical standpoint, but maybe perhaps, let's for example, TreeDN provider A might have in their domain, 100 different relays, and they give those 100 different relays the same Anycast address. So so you will get routed to the nearest one, and that gives you load balancing, it gives you load splitting, it gives you traffic localization. So you hit the nearest topologically optimal relay. Now, what if there's TreeDN provider A and TreeDN provider B, and they have different relay addresses? Which one should you use? Well, I'll ask you this question. How did the end host, the receiver, find the group address? Somehow they found it, presumably through the application layer. And I already said, if you can find the group address, you should be able to find the source address. If the application layer is telling you the group address, the application layer should also tell you the source address just as easily. And for that matter, the application layer could also tell you the relay address. So it can give you a hint and say, hey, here's the source, here's the group, and here's a relay that we know will work. You should try that. You could try
like BGP.
And BGP is, of course, BGP is the answer to everything, right? But I'll channel Jeff Houston and say, F it, just use DNS. And that's the next short answer is you could just use, and that's essentially what we've done. And we have actually a global TreeDN network, and I would invite your viewers, check it out right now. We'll wait till this episode is over, but check it out. Go to menu.treedn.net. It is the multicast menu. It was developed by a brilliant, at the time she was a high school student. She was a sophomore in high school. She developed this webpage and kind of worked on it throughout her high school career, as this was her senior project at Thomas Jefferson High School in Alexandria, Virginia. It was Lauren Delwich. Like I said, she's brilliant. She's in college now, but this was her high school project. She developed the multicast menu, and what we did with that was there are a global pool currently of 4 global AMT relays, and we just use DNS, and we have, each one of them gets their own, we have a well-known DNS A record. So you have 4 different A records for 4 different IP addresses, and we let the application layer pick. So what it does is we've hard coded that into VLC. So VLC, for those video LAN client, has AMT built into it, and under the preferences you can specify the AMT relay, but there's a default one called amtrelay.m2icast.net. I believe that's the fully qualified domain name, and so it will look that up. It will get all 4 A records, and it will try one at a time, and it will whichever one, and it'll keep trying. If it gets no, it'll build a tunnel, send an IGMP report, and if it gets no traffic back, it'll try the next one and go through all 4 of them. That's one way of doing it, and I think we're working on different ways to do it. One idea is we continue that, and you have just this global pool. Use DNS, and you have lots and lots of A records that point to the relay. And what you could do is you could ping each of them and see which one gives you the fastest response, and then try that one first, and go in the order of latency based on your pings. But all things are possible. Andy, there's DNS is probably the best way to go, but the way we do it right now is just using very simplistic DNS, and you randomly pick one that gives you load balancing, that gives you redundancy. It doesn't give you optimality. So something like adding the ability to ping each of them first, that could give you optimality. But these are all things that are possible.
Yeah, practically there are well-established techniques to get to the closest one. I mean, every public cloud is using DNS to do exactly that, right? So yeah, people know how to do it.
So probably a question for right at the end. We're right at like a minute from the top of the hour. Are there any working implementations so far, or Or is this still in the proposal stages or beta stages?
Yeah, I mean, the good part is from an implementation standpoint, these are protocols that have been implemented for years, well-known, open, standards-based, as opposed to most CDN technologies, which are kind of, there's open caching, but generally speaking, most caching architectures are kind of proprietary. They're not really interchangeable, and there's a lot of complexity, and they can be kind of expensive. So TreeDN is about an order of magnitude cheaper to deliver this content.
Mm-hmm.
And in terms of implementations, anybody who runs any kind of native multicast, PIM-SSM, beer, MLDP, point-to-multipoint, MPLS, any of these anybody who implements those things can function in the native part of the network. On the AMT side, Juniper and Cisco both have AMT relay implementations. There's also an open source implementation. Jake developed that, and folks use that all the time. So from an implementation standpoint, the tools are out there. From a deployment standpoint, yes, there is the global TreeDN network that I mentioned. If you go to menu.treedn.net, you can see this. You can try it out. You can see some real streams that are working over the network. It's basically a bunch of Internet 2 members who have built a network and are sourcing some interesting test streams, and we're trying to get more streams. We'd love to have more people join the party. So if you want to be part of that network, it'd be great. There are 2 other deployments to be aware of. Géant is the RNE network in Europe. It's kind of like the Internet 2 of Europe. They have been running this, and they have a customer. They talked about this at IETF. They gave a great presentation. A customer called EUMETSAT, EUMETSAT, which is it's an organization. It's kind of like the NOAA of Europe, National Oceanographic Atmospheric Administration. That's what EUMETSAT is. They're kind of like that, but for Europe. And they are operating a bunch of atmospheric satellites doing weather and meteorologist stuff and atmospheric data. And they're streaming telemetry to high bit rate telemetry streams real time to research institutions across the world, universities and the Weather Channel, and that's how they get this kind of satellite data. They use Multicast, they use Géant as the transport network. So Géant is kind of the TreeDN provider. They have AMT relays, and EUMETSAT is the TreeDN provider. So that's a really exciting and interesting, and they're making real money out of this. And again, the EUMETSAT people have said it's an order of magnitude cheaper than using unicast-based CDNs. And then there's another interesting network, and Jeff, you'll love this. In fact, you're probably familiar with them. And this is the RareNet Rare network. That's another. It's run by the folks at Renatur, which is the NREN of France, and they have built a global network of beer routers running on Tofino P4 switches, and they implemented beer, they implemented AMT, and so they have the combination of beer and AMT, which you mentioned earlier, which is a really exciting and interesting fusion of technologies.
We've got statement questions or statement. Not everything is 4K, which is true, but I think it's orthogonal to this discussion. I mean, for TV makers to sell next generation of TVs, you need better encoding. So inevitably we'll go into 4K, 8K, 16K, or whatever is coming. Otherwise, why would you buy a new TV?
Yeah, and the other thing is, like, it doesn't stop there, right? Think about AR. What if I could throw on some AR goggles and get that experience of what it's like to sit at a Golden State Warriors game, front row, center court, right? And to the left of you is Adele, and to the right of you is Mark Andreessen, and you could listen to the Adele and Mark Andreessen talking to one another, and across the way you see Jay-Z and Beyonce, and you can watch Steph hitting threes and Draymond getting in fights and kicking people, and you could get what that experience is like to sit front row, center court. To get that in the real world, you'd have to go to San Francisco. You'd have to pay $50 to park, you'd have to pay $10,000 for those front row center court seats, and you'd have to pay $17 for a beer. What if instead you could get that experience by slapping on some goggles, sitting on your couch, and looking to the left of you and seeing Adele and seeing Mark Andreessen and Jay-Z and Beyonce, and you could see the game in front of you. You wouldn't pay $17 for that beer. For $17, you could get almost a 12-pack, and it'd be your favorite beer, not, what they sell there. You wouldn't have to go all the way to San Francisco. You wouldn't have to park, and you could get that experience, and you wouldn't have to pay 10 grand. Maybe you pay, I don't know, $200-$300 for that experience.
I'm completely.
Let's say that's a 500 to 600 meg stream, AR stream, that's live streamed. That's a high bandwidth stream. Can the internet today support 500 meg streams, 600 meg streams with a million simultaneous viewers, right? Can it do that today? I don't think it can. And if it could, it'd be really, really, really expensive and not very viable. So it's really about not just making the stuff we have today a little cheaper, because look, Amazon and YouTube, they're doing it. They're doing brute force unicast, and they're making it work, and it works reasonably well. The question is, can you go further? Can you go to that immersive experience, and could you scale to tens of millions of viewers simultaneously? I don't know that you can get there, but this is an architecture that does get you there. And the last thing is, this is a really democratizing technology. Like, is it healthy for the internet and society that only a handful of companies and organizations control pretty much all distribution of content? Like, is that healthy for society? This is a technology that gets the internet back to its decentralized roots, that anybody can, start sending a stream at 4K or whatever, or maybe even AR, and they could reach an arbitrarily large audience because they're only sending one stream into the network, and the network intelligently replicates it for them. And they could reach, say, tens of millions of viewers. This is a technology that makes that possible.
So there's last question. I missed it. Why not Anycast? I think I can say why not. Actually, you need a combination of both. You need DNS to resolve, because Anycast, any IP address is scoped to a particular IS, right? To a particular administrative domain. So you need to resolve this address, and then you could do Anycast to this address within your domain. So it's pretty much like anything else you would use at scale. You need resolution, and then you can deploy it locally.
Yeah. So you could use DNS to resolve a bunch of different Anycast addresses, and then that IP address could be an Anycast address that represents a bunch. So, as they say, there isn't a problem in computer science that hasn't been solved with another level of indirection. And there you go. Between Anycast and DNS, you have two levels of indirection there that gets you to scale.
And with that, we probably ought to wrap up here. I loved your last comment on democratization. I think that's a perfect cap on this entire discussion. Lenny, thank you so much for joining us and taking the time to explain TreeDN to us. Really enjoyed all of this, and look forward to maybe having you on in a later show.
Love to do it. It's been great. I really appreciate you guys having me, and this was a fun conversation. Thank you.
Great.
Let's agree to see you maybe in 6 months and see new exciting developments here, new providers, new people using it, because it just makes sense.
Absolutely.
Look forward to it.
All right. Thanks, guys.
Thanks, everyone. Thanks, Lenny.